Sir, good morning, sir. We are discussing another type of design pattern, that is prototype design pattern. It is also belong to a creational design pattern. Creating a new object instance by cloning copying the other object. The main aim of the prototype model is the prototype itself name suggests itself as a clone, links copying of the one pattern to the another pattern. In manual testing also we are studied about that prototype model. It is also called as dummy model. So instead of creating the original model 2 to 3 times, by copying and creating the dummy model, we can attain the same output by with the help of prototype model, and it is one of the very easiest type of design pattern compared to another 23 pattern in Java. It allows adding of any subclasses instance of a non superclasses at a runtime. That means, for example, let me consider as a one robot. Building a one robot is very high expensive and as well as very risky. So once after original robot is created, we will by taking the cloning, means by copying the same robot, we can implement it like another features. For example, ears, we can provide ears as a one copying of the model, and again we can copy the original model, and for that we can provide some four eyes like that. For example, by using this prototype we can do that. When there are numerous potential classes, then that you want to only use in a needed at a runtime. Okay, reduce the need of creating subclasses. As I told you, it will reduce the creating the subclasses. For example, here is this UML diagram example for the prototype pattern.
Yeah.
Here client.
Hold on. Go back.
Yes, sir.
Okay. So just let's discuss a couple of points here. Okay. So
Okay.
can you tell me only one term which you see in this description, which in fact is the key term for this design pattern?
Clone.
So with this word clone, it completely describes the prototype design pattern. And how?
Yes, sir.
Like we say when you have a house construction, right? You have a big building.
Yes, sir.
To be constructed, then you prepare a prototype, right? So
Yes,
that
sir.
prototype will have exactly the same structure, same design, color combination, everything, right? So that is a prototype.
Yes, sir.
Similarly,
Yes, sir.
when you have this object, any object you have defined, then you want to create a copy of that. That is
Yes.
called prototype.
Yes, sir.
Okay. So another thing is, can you try to tell how it helps you?
Yes, sir. It reduces the it reduces the creating of the subclasses. Suppose if we got 10 to 12 subclasses, by doing cloning, we can reduce that one.
Okay.
Then instead of typing, sir,
Yeah,
for example, in Java program, instead of taking the full program, we can copy the some program and we can modify.
Yes.
With the help of cloning.
What does it mean? You can modify.
Sir?
What do you mean by that you can modify that object?
Cloning. For example, if I want to get the output of A plus B is equal to C, for that I type a complete program. So in next output, I want to get the output of C minus D. So by copying the entire program and paste by cloning it, by changing doing some simple modification, we can get the entire output.
Okay. Yeah, that's right. So let me add one more very simple example. Okay.
Excellent.
Say you have a student object. Okay.
Okay.
Now in that, let's take few properties which are common.
Okay.
So, common. What are the common properties in a student object?
Like name, age, roll number, etc.
No, roll number will not be same for multiple students.
Common. Okay. Name.
Which properties are same? Common.
Name.
Yes.
Then gender.
Name will not be same, right? How two students' name will be same. Gender also.
Oh, like same.
Yes, gender will be same. But name.
Gender name, then college name.
Give me 1 minute. मैं मीटिंग में हूँ बाद में फोन करता हूँ. Yeah.
Yes, sir. Gender, then
Gender also may not be because there might be male and female.
then school and college name.
Institution name. Then
Age, because they are studying in one class only, they have to be same age.
not necessarily. Sometimes you will have an elder or younger also.
Okay, then address, college address.
College address, correct.
Then teachers for each subject.
Yes. Subjects itself and also teachers for the subjects.
Yes, sir.
What else?
Class
Well,
timings.
I want to ask others.
Class timings.
Yeah, you think other properties. I want to ask other people. Anki, tell me couple of properties which are same for a student object.
Polymorphism. In polymorphism. Kafla, can you repeat one more time the question?
Yes. No, I must. Okay. So, for a student object, when you are defining a student object, it's not specific to Java or any programming. For a student, okay, or two student or multiple students, there are few properties or few feature which is common. Like for example, college
Student,
name
student.
for the students is same.
Okay, bus route.
Bus route, how it can be same? All students come from a different location, right? Their route,
Same region or
region, city might be same. That comes under address.
pin code.
That's what I mean. That in everything under school address it is same. Or pin code also. If you say student's address, then it
Phone, a different phone number and different
college contact number might be same.
and Aadhaar card number.
No, Aadhaar card number everybody has you. Do you think? Afrin, tell me, couple of.
Sir, their college might be same or teacher subject, college address.
No, this already we told. No, tell me something which we did not tell already.
Their marks can be same.
No, how marks can be same? But subjects total marks can be same, but individual students will have a different marks, right?
Same friends.
Come again.
Same friends.
Same friends.
Yes.
No, that is not relevant. How it can be same friend? It can be, it may not be also. But like,
same thoughts.
No. See, it maybe it may not be. Okay, but I'm asking what are must be. Like college name must be same. If 100 people are studying in a college, then college name for all students is same. Okay, so like that.
Surname.
No, not necessarily. Surname could be different for different people.
Sir.
Kahinde? Yeah, I'll come back to each one. Kahinde? Can you tell some property which is same among the students? Okay, Jivan, come back. Tell me.
Sir, college starting timings, then ending timings.
Is same, correct.
Each and every period timings. Then principal, name of the principal.
Teacher, same, yes.
Teacher, same. Then
exam date, same.
Exam date, same. Then exam timetable, same.
Right.
And then
good enough. Yes.
Uniform.
Correct. Uniform is good enough. So, point is, see, when you are designing a student object, then out of the total 15, let's say there are 15 properties. Okay. out of 15 properties, or let's say I'll give a bigger number. There are 50 properties. Okay, out of 50 properties, there would be many situations where 40 properties are same.
Yes, sir.
Or I can percentage wise, I would say that 80 to 90% properties are same.
Yes, sir.
Okay, let's say. Then you created one object, student. Okay.
Yes, sir.
Now, what will happen is, if you have to create, let's say you have 100 students. So you have to create 100 objects, because everybody's
sir.
ID would be different, name would be different, but 80% is same. But still, they are different objects because their ID and name is different.
Yes, sir.
Okay. Now, in that case, if I create one object and try to set all properties again and again, then it will be a huge time consuming and also resource consuming.
Yes, 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 sir.
So in that case, what I'll do is, I will create one object. I'll set all the properties for one student. Okay.
Yes.
Then I will clone it, create a copy. So now both copies are same, but the new copy which I got, in that copy, I will just replace the student ID and name.
Yes, sir.
Done. So now you say I have how much time I have saved to create one more object by copying mechanism, right? So that now that mechanism I will repeat it for 1,000 students. So
Yes,
for
sir.
1,000 students, only ID and name I have to change. Remaining 99% of the data remains same. So I don't have to set that data for 1,000 students. So that is how.
Yes.
So this is a use case when you should use this copy method or prototype design pattern.
Yes, sir.
Okay. Yeah. Go ahead.
So as I sir told you now, I created same example, but not for the students, for the animals. So here is the UML diagram. So clients, suppose, let me assume there is one animal interface class, that is a prototype class, and prototype factory as a prototype. Suppose client, and sheep and dog as a subclasses. Suppose client want sheep to make a copy. So client first need to approach to the factory. The factory will approach to the prototype. Then prototype of the animal will approach to the subclasses. So after that, we can make a copy of it. So let me see the same thing in the example. See, first I created the animal as an interface. See here, I'm creating the prototype, a public interface, animal, extend to the clonable. So we are doing the clonable over here. See, extends to the clonable. So we can do the animal as a copy. So after that, we doing the cloning. So for the public class, we need to create it in the public itself. If it is going to be private, means no one can access it. So public class clone factory. Here I'm creating the clone factory of it. Then public animal get clone. Then I'm getting the clone of the animal over here. After that animal, let me take the sample of the animal, then return animal sample dot make copy. I'm making the copy of it. As I told you, client need the sheep. Okay. So here I'm doing that exact thing what I'm implemented in the animals. See, public class sheep implements to the animal, then public is equal to sheep. So I am printing sheep is made in the system.out.println. After that, public, I'm doing the animal as a copy, and I'm doing the copy of the animal. Then I'm again printing the sheep is being made. After that, if sheep object is equal to null, then I am trying to print sheep object is equal to sheep super.clone. I am doing the clone as a super class. After that, catch clone not support. This is the code what we are doing. So e.print stack trace, we are tracing that one. After that, return sheep object. Here I am using the string to print hello GTS, because I am here showing the two instance. See, one we are cloning. So main what they called as main program output is stored in one file, and after doing the cloning, it is stored in another file. If you take as an example, see, in test cloning, I will show you after running the program. See, I am printing that Sally and clone sheep, and as well as Sally hash code. Why I am using hash code means through that hash code, we can easily identify we are doing the cloning or not. If we have done the cloning, so each and every code is different in hash code. If the cloning is not done, then hash code will be the same. So I need to print Sally and clone ship, and I have to check whether the cloning is done or not. I will do the I'm accessing the program. See, ship is named as the first output, then ship is being made as second output. See, allow GTS as stored in both clone factory and as well as sheep factory. But see, in Sally hash code, the code is all different. So the cloning has been happened. If the cloning has not been happened, then Sally hash code and clone hash code will be the same because it is stored in the same file. After doing the cloning, the file will be not same. So it is showing some different hash codes for that. This is all about prototype model. Sir?
Yeah, right. Anybody, any question? Move on with the next topic.
Yes, sir. So next, last topic in creational design pattern is builder design pattern. This pattern is used to create object made from a bunch of the objects. And when you want to build an object made up from another object, we were using the builder pattern. When you want to creational of these parts to be independent of the main object, then we are going to use the builder pattern. The creation of the parts of the client so that both aren't dependent, then we are going to use that builder pattern. The builder known as a specific and nobody else does. Basically, this is very complicated thing to understand by seeing the definition. So let me going to take some real-time example and I will explain it my own. For example, this one is completed.
Description.
Yes, sir. For example, let me take some basic example, day-to-day life examples.
No,
let me take
these points. Yeah.
Sir?
Elaborate these points with example. Okay?
Yes, sir. Yes, sir. That's what I'm doing. Suppose let me create an object. So for that, I need to create two objects. For example, let me take one object as car and another one object as bike. So I need to implement it by part. We can't implement it directly. For example, first we need to select the engine, after that 4 tires, after that gear, after that clutch, and each and everything we need to implement it individually. Like that, we need to implement exactly for the car, exactly for the bike. See, mainly builder, as the name suggests, builder. For example, if we want to construct the house means, first we need to construct the basement. After that, we need to construct the first floor. After that, molding. After that, second floor, like that. Individually, we are building. So let me take the example as robot. So first, client have to make a robot. For that, we need to create a robot builder interface. In that robot interface, see,
add a couple of points. Then we'll come to this robot example also. Go back.
Which one, sir? Here.
Yeah. So here. So you actually try to say car and bike together, okay? So
yes, sir.
No, it will not apply like that. It will apply if it is only car or only bike.
Okay? Yes, sir. I just taken as example. That's it, sir.
In the example, okay. So let's say
both are different. Both are different. If we take the car means for the car we need to implement part by parts. If we take bike means we need to implement it part by parts. Yes, sir.
So let me elaborate or add a little more to that. So let's say
Okay, sir.
I want to build a car. Okay, so I need a pattern. That is saying in the build pattern, the final product which I want to make, final design, okay, it is normally consisted of other small parts. Okay?
Yes, sir.
So one car is made up of engine, frame, its windows, then seat, okay, music system, or all other accessories. Okay, brake, okay, oil, place where you will keep the oil, all these things.
Yes, sir.
Each of those parts are built in different manufacturing center,
Yes, sir.
and those parts are built independently. Okay,
Mhm.
now those parts are built independently and they are being supplied to different car assembly centers.
Yes.
Okay, so the place where we are assembling the cars, okay, by using those parts, they don't know how those parts were
Made.
manufactured.
Yes.
Right? So in the design pattern, we basically will design the classes and objects separately, like all those parts, so that the person who is assembling those objects, they don't know, they don't care how they are manufactured, but they do know, they need to know functionalities of those objects. What is the
Yes.
properties? What are the functions available? So that accordingly they can pick up and assemble together to make the car.
Yes, sir.
All right, but whatever you said, that was correct. I just wanted to add to it.
Yes, sir. But I will explain in a complicated way. I don't know how to explain that one. Now I got to know that how I need to explain it after hearing to your lecture. So I can explain in the upcoming classes.
Sure.
For example, as I sir told you, I will explain the same thing in the robot. For example, client wants to make a robot. For that, we need one interface. In that interface, see, we are building each and every parts like head, torso, arms, legs, or in different, like for example, let me take it as different factory itself. Okay, but at last we want at last client want to make a robot. That's it. So for that, we need the old robot builder because set fields are robot built using the specific specification. For that, the same thing we are going to implement it here also. For building the robots, they will get that robot and they will make the robot like a new one. After that, robot going to be planned, like define all the methods of the robot must have. Like for example, if the robot we considered of like arms, legs, torso, head. At last, what we are doing is we are planning to build that by getting all the all the parts of the robot into one robot. That's what the client wants. Let me take this one also, then my program also. See, first we need robot builder as an interface. So in that, what we want is we need to build robot head, we need to build torso, we need to build arms, we need to build legs. After that, we will move towards the old robot method. So in that, we are providing what and all parts will be done through what and all types. So for example, see, we are building old robot builder is equal to new robot. After that, we are going to the public void build robot head. For that, set robot head is equal to teen head. Teen is nothing but it is specific head, what the client want. After that, we are building teen torso. After that, we are building blow torch arms. After that, we are building roller skates for the legs to move. If the robot wants to move, means we are using roller skates for the move. So like that, after what we are going to specify in the old robot builder specifically, then we are moving toward the robot engineers who are building the robot. What robot engineers will do, they will take the robot, old robot, and as well as they will build a robot. See, here robot builders is equal to see, not that one. See, in public, robot is equal to get robot. After that, return this robot builder is equal to get robot. These are all the codes for the head, torso, and as well as arms and as well as legs. This is once our robot engineers done with their plans, then we will go for robot plans. Here we are providing through the strings head, torso, arms, and legs. It is nothing like more complicated in the program because I'm also learning, so I done with the basic program itself. So once after the robot is created, we need to go for the robot.java. In there, we are implementing through the strings as robot head, robot torso, robot arms. We are using that same public string and void mains here also. If the public string robot get robot head, then return robot head. After that, we are going for the same thing for the torso, then arms. After that, then we go for legs. We are building the same thing for each and everything what we are printing in the old robot. After that, we need to test that whether we are building the proper robot or not. Then we will go for test builder. We need to test. See, we are providing public static void main string array args for the output. Robot builder is equal to old style robot. What we mentioned over here is equal to new robot builder. It going to build the new robot by attaining the knowledge of old style robot. After that, robot engineer is equal to robot engineer new robot. We are building the new robot by using the old style robot. After that, robot engineers dot make robot. Robot engineers will make new robots. Then after that, we are providing how to build. Then we are building robot head type plus first robot get robot head. After that, torso type first robot, same thing for each and everything, for the torso also, for the arms also, for the legs also. We are defining types over here. If we run this program, we are getting the output as robot build. See, exactly the same output. See, first we are building the robot build over here. After that, robot head, but we mentioned that it has teen head in the old robot system, so it is typing teen head. After the torso also teen torso, then blowtorch arms, then roller skates. See, we are building each and every we are building robot in different steps by providing means different parts, but at last we are building the robot. This is how the builder design pattern will work. This is all about builder design pattern.
Yeah, good. So let me add a little bit more. Okay.
Yes, sir.
So expand the the file names. Move that vertical line to right side. After the file names, you have that vertical line, no? That the old that move to the right so that I can see all the file names. Okay. Yeah. So let's focus on this set of classes. This is what is your design pattern, right? So in
Yes,
this
sir.
design pattern, what you have to do, you have to build a robot.
Yes, sir.
Okay. Now to build the robot, you have builders, you have engineer, you have plan, and then you are testing the builder. Right?
Yes, sir.
Now if you open the builders,
Yes.
now.
Yes, sir. Yes, sir. Same thing. This is the robot builders.
This is the robot builder. Okay. So in that, see what you are doing is this is the interface. This old you have opened the. Can you keep the mouse right click on the robot builder? Click on the robot builder in the left side.
Yes, sir.
Okay. So robot builder is your interface.
Okay. Yes, sir.
Now in the interface you have given that I want to build a head, torso, arms, and legs.
Yes, sir.
Okay. Now you may have a different section in your unit. People who knows only to manufacture head, design the head. Okay.
Yes, sir.
They will do it independently. Okay, they do not know how it will be used, but they have to be in sync with how the hand can be fit into the other component, right? So hand has
Yes,
to
sir.
fit in the body. So it is not 100% independent, but they work in sync with the other modules. That is why they have kept it inside a interface. They could have a
Yes,
separate interface for the head, arm, and leg, right? But they did not do
yes,
it
sir.
because they want it that someone should these arms, head, and all, they should be in a sync. Like if you are making a robot of a human, okay, versus you are making a robot of a, let's say, an animal or elephant, let's say. So the leg of an elephant and human won't be same. Procedure, steps, and technique would be different. So
Yes, sir. That's
if I am trying to define or build the legs for animal, then I will have a separate interface where animal related all components will be together, and I'll create an interface. But here you have this robot builder. This will be for a specific uh, you know uh, or the particular type of robot for which we are building this interface. Okay, then these individual parts are built separately, and then we are assembling them inside the builder class. So open the old builder class, old robot builder. So this is the robot class where I am implementing the interface, and then I am trying to assemble them one by one.
yes, sir.
That's all.
Sir, for this one, I got an idea. As you said, animal leg is different, then human legs are different.
Ah,
For example, if client wants to build, let me take, yeah, the client wants some car also, then bike also. So by using this builder pattern, can I build?
yeah, you can do it. So all what I try to mean is all the common features need to be assembled together, or you should keep it in a same interface.
Like if tires also same for both, then horn, then tor, then light. For that we need to create one. For the car, let me take the example as airbag. So that will be different because bike won't get the airbags, na?
Right.
Okay,
So in that
okay, okay.
case, if you have a common interface, what will happen is when you design for bike, then even though you don't have to use a airbag, but still you have to implement it by keeping
Yes.
some default. So it will be useless in case of
Mm-hmm.
bike.
Okay.
So you should
Okay.
design the interface only when all methods are required for all its subclasses, for all its
Okay.
children.
Okay. Okay, sir. Okay.
So sometimes it is difficult, and it happens that we designed in the past some interface, but now I out of 10 methods I need only 5. So the
Okay.
remaining 5 methods by default I have to still define it in my class. So those are a bad
Mhm.
design, but like a bad design in the sense like they did not visualize that what is going to happen in future.
Okay. Okay, sir. Now I get it.
Okay, cool. So you have completed all 5 design patterns from creational type.
Yes, sir.
Very nice, very nice. So now you are learning basics of Java along with that very good thing of design pattern.
Yes, sir.
Okay, good. So I just want to call out one thing. Even today, there are people who has even 10 years of experience of Java. If we ask some basic or mid-level questions on design pattern, even in creational, they can't answer. Okay, but
Mm.
this is the advantage of this training, right? See, everybody
Yes, sir.
can do it. Everybody has enough memory and intelligence to do it, but nobody is there to guide you to do it.
Yes,
That
that's
is
true,
where is
sir.
the problem. Or else everybody can do it. See,
Yes.
now, though you were not, you were feeling very tough in the first 2, 3, sessions, but now it is easily you are doing. But you are doing a hard work in the back end. That I understand. You are watching
Yes.
multiple videos. You are reading and trying to understand and doing the self study.
Yes.
But I
By seeing that. Yes, by seeing one or two videos, it is very tough to understand. So I need to go with the 2 to 3 videos, then 2 to 3 definitions,
Hmm.
2 to 3 examples, flowcharts. After that, I am getting to know that. That's why I'm go. It is a couple of days I'm taking to learn these things.
And with this speed, if you go, you can just imagine in next 2 months what all things you are going to learn,
Yes, sir.
right? So all the best.
Yes, sir.
Keep it up. And
Yes, sir.
yeah.
Sir, today I got internals in QSPADAS, what I'm taking in online.
Okay.
So I need to attend that one. I need to study for that one regarding the manual testing.
Uh-huh. Okay.
So shall I walk out of this meeting, sir? So I need to study that one.
Yeah, should be fine. That is okay.